This is Structure and Function ALHS 1011. It's now Module 2, and we are in Chapter 3 with the integumentary system. Here are your learning objectives. Okay, so as I mentioned in one of the previous videos, the integumentary system is not just the skin. It's composed of skin, hair, and nails, and any associated glands. The skin, our largest organ, very, very important, weighs about 20 pounds. It can cover, I don't know how they figured this out, but can cover 21 square feet of an adult skin. There are three main layers: the epidermis, dermis, and then sometimes we call it the hypodermis, but it's the subcutaneous fascia. The epidermis has several layers. We are not going to ask you to memorize these layers, but the epidermis is avascular. It has 5, which means it has no blood vessels. It has 5 layers. The stratum basale is the deepest layer, closest to the dermis. You can see it down here. It's actively making new epidermal cells. And it's simple, which if you remember from the tissues lesson, it's simple means it's one layer, single layer, and it's cuboidal, which means it's cube shaped, and it's epithelial. And then we have the stratum spinosum, which is maturing cells. So you've got the basale, which is creating new cells, making new cells, dividing. And then in the spinosum, you have those cells are maturing. In the stratus granulosum, those cells contain keratinocytes. And what that does, keratin waterproofs our skin, okay? The stratum lucidum is found only in thick skin. So that's the next layer right here, just beneath the surface. And the stratum corneum is the most superficial layer. And this is the layer that flakes off continually as we go about our day. It's dead, keratinized, waterproofed cells, and they flake off. And this would be the layer that you would exfoliate or remove. Okay, and here's another, this is a great picture. You have the basale, the spinosum, the granulosum, lucidum for thicker skin, and the corneum. And then this top layer, you've got exfoliating cells. And keratin is located in this, and that was, remember, the waterproofing. And then you've got a basement membrane that divides the epidermis from the dermis. And skin cells kind of divide and rejuvenate and mature and move up and then get sloughed off. So other cells within the epidermis are melanocytes, which produce melanin, which is our skin color. We also have tactile cells that are receptors for fine touch, dendritic cells, which are, if you remember from the axon has a dendrite, which brings in sensory input into the nervous system. So it's also can alert your immune system. Keratinocytes produce that waterproofing keratin. Okay, skin color. So let's talk about that for a second. Located, it's deep in the epidermis. So it's in the epidermis, not quite at the corneum. Some melanin is, but the melanocytes are deep within the epidermis. And melanin is the substance that causes the skin color. And there are a lot of variations, obviously, with skin color. And it really has to do with how the melanin is distributed, not the number. So it's not, if you have darker skin, you have more melanin. That's not the case. It's not the number of melanocytes. It's just how it's distributed. And freckles are patches of melanin. So here's some variations in skin color, and sometimes they indicate disease for us. So carotene, um, found present in carrots, can give a yellowish tint. Hemoglobin uh, gives a pinkish tint to our skin. So let's talk about these other ones. We've got Addison's disease, and that person has like a bronze color to their skin. Albinism, those people have a have a more pale appearance. Erythema means redness. Cyanosis, you can see around those babies' lips, the blueness. And then jaundice is yellow, where carotenemia has an orange tone. If you ever fed a baby carrots, a lot of carrots, and they love carrots, you ever notice that their nose sometimes looks a little orange colored, or their tips? That's the keratin. And here are some of our beautiful skin tones. And in the world where light, obviously near the equator, you find darker skin, and as you get away from the equator, skin becomes lighter. So as we mentioned, disease can affect skin color. So liver disease means the person can become jaundice, which is a yellowish tint, and the body cannot break, what happens is the body cannot break down bilirubin, and they become yellow. I showed you a picture of Addison's disease, and what that is a malfunctioning of the adrenal gland, and they end up turning bronze due to excessive melanin. Ecchymosis is a fancy word for bruising, and sometimes excessive bruising or blood circulation problems, you can end up with cyanosis or blue color. Okay, epidermis. Oh, we've discussed that. Here's the dermis. Okay, so next beneath the epidermis is the dermis, and we call this the true skin, because this part of the skin. So we've got the epidermis on top, which is a lot of cells and tactile cells and melanocytes and epithelial cells. In this dermal layer, dermis, you see the middle layer, we've got a lot going on. We have capillaries. Remember, the epidermis is avascular, no vessels. We have collagen, elastic fibers, you've got muscles, you've got nerve endings, you've got lymph vessels, hair follicles. This big, beautiful thing here is a hair follicle. You have sudoriferous glands. Sudoriferous glands are sweat glands, and sebaceous glands are oil. And some unique properties about the dermis. The dermis will blush because it has blood vessels, remember, capillaries, and when they dilate, we get that nice pink color. Turgor means the ability of the skin to return back to its normal shape after being pinched or deformed. So I always tell the story, I used to think it was funny that I used to pinch my grandfather's elbow, and it used to kind of stay squished, kind of looking like this picture, because as you age, you lose skin turgor. I don't think that's funny anymore because mine does that now. So elasticity, we have elasticity, we have turgor, but that kind of decreases with age. So we've got the epidermis, the epidermal ridges, and then where the epidermis and the dermis meets. And we call that, I'm going to just move this little thing over here. The top layer of the dermis is called the papillary layer. And it has like cone-like ridges called papillae. And they're all over the body. And that's what gives us our fingerprints and toe prints. So this is what you would see under a microscope. That's the papillae, or the kind of ridges on skin. The reticular layer of the dermis is the next deep layer beneath the papillae. It's got collagen fibers, it makes cleavage lines, it's deeper. So like in your hands, unlike your fingerprints, which are kind of finer in the papillae layer, in the reticular layer of the dermis, we've got our creases, our cleavage lines. We've got folds in your joints. In this layer of the dermis, we feel pressure, we feel pain, warmth, and cold. Okay, then below the, and you can see it in this picture, we got the epidermis, the dermis, which has got all the stuff, and then the hypodermis, or we also call it subcutaneous fascia. And that's the innermost layer of the skin. So hypodermis. It's composed of elastic, fibrous, fatty tissue. It's a lot of fat in this layer. So lipocytes, fat cells, are producing this insulation and keeps us warm. Okay, so if you ever had a subcutaneous injection, it's going in this layer. Okay, and the fascia attaches our skin. It's kind of gluing our skin to the muscles. Okay. So some nutrition that we need for healthy skin: vitamin A, vitamin C, very important because of collagen. And those things can be found in green, yellow vegetables. The more color on your plate, the better. Dairy products, liver. And then vitamin C we find in fruits and green vegetables also. So good food for skin. Okay, sebaceous glands are oil producing, or sebum. Sebum is the correct word for oil. And they are, sebum is, like I said, the oil. It keeps the skin drying out. It kind of keeps us nice and well preserved. It also has a mild acid in it that acts as a antimicrobial. So it destroys pathogens. And it's found all over our body, but a lot of sebaceous glands are found in hair-covered areas, the eyelids, the penis, the labia minora, and the nipples. I'm not sure how to pronounce this, but meibomian glands will secrete sebum into our tears that coat the eye. So they're specialized sebaceous glands. When we get, sometimes sebum is not our friend, and when we get excess sebum, we can get acne. And this happens kind of with puberty. Estrogen and testosterone will tend to increase sebum production. And a pimple, or comedo, a pimple is a comedo. What happens is that excess sebum plugs the ducts, and bacteria gets trapped, and then you get a condition known as acne. And a lot of times this is an unfortunate occurrence of puberty. So your sudoriferous glands, a little different than sebaceous. Those secrete sweat, and the body has 3 million sweat glands. It's apocrine. We secrete at our hair follicles, so we have more sweat glands in our groin, anal region, armpits, and these are activated at puberty. And we give off an odor in our sweat that kind of acts as a sexual attractant. So just like animals, we kind of give off a pheromone smell that is a sexual attraction. When normally the chemicals activated are odorless, but when the bacteria starts to decompose, then you get the smell. So think about it, after the gym and you've sweated, decomposing bacteria is making you smell, which is kind of not a nice thought. Merocrine's glands are all over the body, and they help us cool us. Ceruminous glands produce earwax, and the technical medical term for earwax is cerumen, so that makes sense. So it's kind of a form of a sweat gland. And then we have mammary glands that produce milk in breast tissue. Okay, moving right along to hair. The purpose of our hair is to help us regulate body temperature. It functions as a sensor, helps us detect things on our skin. The eyelashes protect the eyes from foreign objects. And nose hair, believe it or not, helps us filter out, it acts sort of like cilia, helping us filter out particulate matter. So, when you're inhaling something, maybe it has dust in it or smoke in it, and then you blow your nose, those nose hair fibers have trapped some of those pollutants. Okay, types of hair. Lanugo, if you see in this newborn, this baby is kind of covered in hair. And babies are covered in hair like this called lanugo, and it's very fine, and it's usually replaced at birth. They usually lose this. And it's replaced by vellus hair. Vellus has no pigment to it. It's fine. It's body hair. Women and kids have it. It's light. It's kind of what we call peach fuzz. And then terminal hairs are thick, coarse, and heavily pigmented. So those are a little different. So you can see in this picture, your vellus hair is kind of thin. It may have an oil gland attached to it. It's fine. Your terminal is thicker, more bold in color. So hair anatomy, most of hair is keratin, and that's a protein. Okay. The hair shaft is the visible hair that we see. You have a hair cuticle that protects the hair. You have the cortex, so hair cuticle. You have the cortex, which is the layer beneath the cuticle that contains the melanin or the hair color. So like if you wash your hair and then you wash it in hot water and then you change to cold water, you have, they say you seal the cuticle and your hair looks shinier. I think it kind of makes the cuticle kind of shine, or the cells lay flat. The cortex contains the color, and the medulla is the layer in the middle. The hair follicle, is formed by epithelial cells. There's a lot of rich blood. It's found in the dermal layer. Next to it, you have this erector pili muscle that may make the hair stand up, or a sebaceous gland that secretes oil. It tries to help prevent the hair from drying out. So I mentioned the erector pili muscles, and what that does is it keeps us warm. It makes goosebumps. It helps make goosebumps and makes the hair on your body stand tall or erect. So when you shiver, that creates muscle activity to help keep you warm. But goosebumps are essentially the hairs on your skin standing erect because of the erector pili muscles. Okay. And these hairs create a dead space between the hairs. And what that does is it kind of traps heat. It's kind of like your own little insulating goose down jacket. Here's a microscopic photo of the hair follicle. You can kind of see the cuticle and the cortex, the medulla. And here is a nice also diagram of it. You have the hair bulb, the base, the root, in the dermal layer. Okay. You've got a sebaceous gland here, oil, erector pili muscle, smooth muscle that's going to make it stand up if you got goosebumps. You have the hair root that's just below the surface. The part that comes out of the skin is the hair shaft, and the layers of the hair is the cuticle, the cortex, and the medulla. Okay, hair color and texture. So melanocytes, again, just like providing skin color, provide hair color. So color is dependent on the amount of melanin produced and the type of melanin produced. So darker hair, not necessarily more melanocytes, but more melanin. White hair, less melanin. Red hair, interestingly, has melanin that contains iron. And the type of hair shaft determines the texture. So a flat hair shaft produces curly hair. Round hair shafts produce straight hair. Even the hair has a lifespan. So the hair on your head may last 3 or 4 years, but eyelashes only lasting 3 to 4 months. So this is interesting. You've got dark hair, straight. So she would have round shaft. See the round, okay? And producing more melanin. Blonde, probably a little less melanin, or this pheomelanin, also round because her hair is straight. We've got a more squished or flat hair shaft, so that makes it curvy, and we've got iron in that melanin, so she's got red hair. Here he's got wavy hair, so it's more of a flat, and there's some airspace here, but less melanin is produced. Okay, hair growth. So hair grows, it rests, and then it falls out, basically, is the process. And not all hair are on the same schedule. So we get about a half an inch a month for about 3 years. And then it has a 1 to 2 year resting stage, and then it falls out. And 90% of the hairs on your head are in the growing stage. We lose 100 hairs a day on our scalp, every day. Okay, moving right along, we've done skin, we've done hair, now we'll talk about nails. Nails are specialized epithelial cells originating from the nail root of the nails. So you've got, there's some keratinization here, and the whole point, the whole function of a nail is protection, protecting our fingertips, okay? We typically grow 1 millimeter a week. There is the cuticle. You may have heard cuticle before, and that's the part where the fold of skin where it covers the nail root. The eponychium is the technical word for that, eponychium, cuticle, okay? You got the nail body, which is the visible part that you think of as your nail. You've got the part that is exposed over the tip of your fingertip is called the free edge. So the entire nail body covering your finger and the free edge, the nail body plus free edge equals nail plate. Call that the nail plate. The nail matrix is just beneath the cuticle, okay? And that's a layer, that's where the nail grows from. It's rapidly producing cells. The kind of half moon shaped white area of your nail is called the lanula, okay? So functions of our integumentary system, it essentially is our protection. It's 20 pounds of protection. It's a barrier, protects us against pathogens, protects us against injury. It helps us balance fluid. It stores some fat for energy supply. It produces vitamin D. So without the sun in our skin, we don't process vitamin D. It provides us sensory input from the environment, and it helps us regulate body temperature. So nonverbal things our skin does kind of as a side gig is it blushes when embarrassed. Remember, that's from the dermal layer because that has capillaries. It gets pale when frightened. And our color, our texture, our silkiness, other qualities of our skin and hair kind of indicate overall health. We can look at someone's skin and hair and learn some things about their health. Okay, how a wound heals. So if you are wounded, for the first thing is a blood clot forms, okay, at the site of the wound. White blood cells migrate to the wound site, and it kind of the blood clot, the white blood cells, and new epidermal cells will grow from there and possibly form a scar. Hopefully the body will repair the dermis and it won't be too much of a scar, but that's kind of the process of how it works. So regeneration is normal, is freshly healed epidermis, and it's not so much of a scar formation. Fibrosis means a scab and then a scar is a result, where the body can't heal enough to make fresh epidermis there. It'll form a scar. Okay, here's a little video on this.
The largest organ in your body isn't your liver or your brain, it's your skin, with a surface area of about 20 square feet in adults. Though different areas of the skin have different characteristics, much of this surface performs similar functions, such as sweating, feeling heat and cold, and growing hair. But after a deep cut or wound, the newly healed skin will look different from the surrounding area, and may not fully regain all its abilities for a while, or at all. To understand why this happens, we need to look at the structure of the human skin. The top layer, called the epidermis, consists mostly of hardened cells, called keratinocytes, and provides protection. Since its outer layer is constantly being shed and renewed, it's pretty easy to repair. But sometimes a wound penetrates into the dermis, which contains blood vessels and the various glands and nerve endings that enable the skin's many functions. And when that happens, it triggers the 4 overlapping stages of the regenerative process. The first stage, hemostasis, is the skin's response to 2 immediate threats: that you're now losing blood and that the physical barrier of the epidermis has been compromised. As the blood vessels tighten to minimize the bleeding in a process known as vasoconstriction, both threats are averted by forming a blood clot. A special protein known as fibrin forms crosslinks on the top of the skin, preventing blood from flowing out and bacteria or pathogens from getting in. After about 3 hours of this, the skin begins to turn red, signaling the next stage, inflammation. With bleeding under control and the barrier secured, the body sends special cells to fight any pathogens that may have gotten through. Among the most important of these are white blood cells, known as macrophages, which devour bacteria and damaged tissue through a process known as phagocytosis, in addition to producing growth factors to spur healing. And because these tiny soldiers need to travel through the blood to get to the wound site, the previously constricted blood vessels now expand in a process called vasodilation. About 2 to 3 days after the wound, the proliferative stage occurs, when fibroblast cells begin to enter the wound. In the process of collagen deposition, they produce a fibrous protein called collagen in the wound site, forming connective skin tissue to replace the fibrin from before. As epidermal cells divide to reform the outer layer of skin, the dermis contracts to close the wound. Finally, in the 4th stage of remodeling, the wound matures as the newly deposited collagen is rearranged and converted into specific types. Through this process, which can take over a year, the tensile strength of the new skin is improved, and blood vessels and other connections are strengthened. With time, the new tissue can reach from 50 to 80% of some of its original healthy function, depending on the severity of the initial wound and on the function itself. But because the skin does not fully recover, scarring continues to be a major clinical issue for doctors around the world. And even though researchers have made significant strides in understanding the healing process, many fundamental mysteries remain unresolved. For instance, do fibroblast cells arrive from the blood vessels or from skin tissue adjacent to the wound? And why do some other mammals, such as deer, heal their wounds much more efficiently and completely than humans? By finding the answers to these questions and others, we may one day be able to heal ourselves so well that scars will be just a memory.
Okay. So I think that was a good visual. The last thing we're going to talk about are burns. Burns can be caused by heat, chemicals, electricity, or radiation. There are two factors: how deep the skin is burned, or the area percentage-wise that it is damaged. First degree is like a sunburn, superficial, affecting the epidermis. Second degree has blistering involved, and that's partial thickness. Third and fourth degree has charring and actually may not hurt as much as second degree due to the fact that nerves were damaged. So first degree, damage only to the outer layer. May be painful, but not blistering. Pain usually subsides in 2 to 3 days, takes about a week to heal. Your second degree has the entire depth of the epidermis and portions of the dermis. Symptoms include redness, pain, and blistering. This can be very painful. It just depends on the depth. Blisters will heal in 10 to 14 days if no complications. Deeper burns take 1 to 3.5 months, and scarring is common here. Your third degree, sometimes fourth degree, are all 3 layers of the skin. So the epidermis, dermis, and hypodermis. And the surface of the burn can feel leathery. It can go from black to brown to tan or white. And like I said, no pain typically because those nerve receptors are destroyed. Sweat, sebaceous glands, hair follicles, blood vessels get destroyed. If you get to fourth degree, these can penetrate the bone. They just go all the way down. And only pain would be felt in the dermal and epidermal layers. Okay. Here's another good visual of how deep these burns are. So this would be epidermal, like a sunburn, dermal and epidermal, and then all the way down, possibly even to the bone as a fourth degree. Now, the amount of the body and the area of the body is important. We call this the rule of nines to estimate when we say someone has a percentage of their body burned. This is the kind of a guide to how, and on a child or an infant, there's less forgiveness for body surface area. And clinically, we want to be concerned. Obviously, our protection is gone, our skin layers are gone. So bacteria, fluid loss, and heat loss. Burn treatment, severe burns require careful measures. With the damaged skin may have to be removed in a process called debridement. If the patient's own skin is used to create a graft, that's called an autograft. If they use a donor or a different person or a cadaver, then that is called a heterograft. Okay, as we mentioned, temperature regulation with skin is very, very important. When the person is hot, then the blood vessels will dilate, maybe causing us to get pink in the face or blush. And we sweat, and that helps us, that evaporation of the liquid helps us cool off. And likewise, when we're cold, goosebumps form, and you can see it here. The hair gets erect, we constrict our blood vessels, might be shivering, and that those hairs kind of create that goose feather type insulation to make us warmer. And here is another graphic of it. And so when we're cold, and all of this is controlled by the hypothalamus. Okay, so the body, remember homeostasis, getting us back to that set point, very, very important. Okay, so that's the end of integumentary system.